Kia ora, and welcome to a lesson on Cambridge Mathematics P2 and P3, the factor theorem. Okay. To understand the factor theorem, firstly you should fully understand dividing a polynomial, which is a lesson I've done previously. So if you've not seen that and you don't understand that, please go back and have a look at that first before having a go at factor theorem, because I'm going to be relating a lot of that to here. Okay, so let's start off with an example. So if I have x cubed plus 2x squared minus 11x plus 6, okay, if I know this is exactly divisible by x minus 2, then what I can say is I can write this equation here, x cubed plus 2x squared minus x plus 6 divided by x minus 2 equals something. And I can work out that using the long division method that we looked at in a previous video. And I would get the quotient x squared plus 4x minus 3. Okay. Where the factor theorem comes from is an idea that I can rearrange this to say x cubed plus 2x squared minus 11x plus 6 is equal to x minus 2 x squared plus 4x minus 3. And if I refer to the x cubed plus 2x squared minus 11x plus c as polynomial x, then what I can say is that on the right hand side I have x minus something multiplied by the quotient x. Okay? And what the factor theorem says is if I was to substitute x is equal to c into p of x and get pc, then I should get 0. Okay? That sounds fancy, but all it means is if I was to, in this equation up here, replace my x value with 2, then all of this will become 0 because 2 minus 2 is 0, and you've got 0 times this, which means 0, which also means that if I was to substitute 2 into here as my x, this would also equal 0, because 2 cubed plus 2 times 2 squared minus 11 lots of 2 plus 6 will be 0. Okay? So that's just this here is just a fancy way of saying if I were to say that x minus 2 equals 0, then x is equal to 2, and then if I resubstitute back in, I will just cancel everything out. Okay? This can go further. Another way of writing this would be to take in the idea that it's not always going to be x minus c, it might be ax minus b, for instance. So a extended version of this general form is that px equals ax minus b qx if we then solve that ax minus b is equal to 0, then we get x is equal to b over a. So if I say p b over a equals 0, okay? If pb over a is equal to 0, then ax minus b must be a factor, and that's the idea that we're getting to here. For instance, if I have a look at a question which is like this, use factor theorem to show that x minus 3 is a factor of this, all I have to do is say if x minus 3 is equal to 0, x must be 3. Okay? If I substitute 3 into this, and it also is equal to 0, then x minus 3 must be a factor. Okay, so let's see if that works. Let's substitute x is equal to 3 into this. So if I say I've got f of x, that is x cubed plus 2x squared minus 16x plus 3, then f of 3 would be 3 cubed plus 2 lots of 3 squared minus 16 lots of 3 plus 3. If I work that out on a calculator, I get the answer 0. Therefore, x minus 3 is a factor of x cubed plus 2x squared minus 16x plus 3. So if we get the solution 0, as in 0 remainder, then x minus 3 must be a factor. Okay? That's the basic version of this idea. Example 2 is a more complex idea here. It says, given that 3x squared plus 5x minus 2 is a factor of 3x cubed plus 17x squared plus ax plus b, find the value of a and b. Find the value of a and the value of b, and b hence factorize the polynomial completely. Okay, so in our polynomial of degree 3, we've got 2 unknowns. Okay, however, we've been told that this quadratic here is a factor. Okay, which means that it's kind of hinting at 2 solutions which, when substituted into here, would give an answer 0, which would then allow us to form a simultaneous equation. Okay, so I would say that 3x cubed plus 17x squared plus ax plus b would be equal to 3x squared plus 5x minus 2 times by, well, in this case it's going to be x plus, let's call it c for now. Okay, all I'm saying is that the quadratic they've given multiplied by another bracket will give me the cubic. Okay, I've not put a number in front of x because I know that 3x squared times x will give me 3x cubed, so that if there was a number in front of that, it wouldn't give me 3x cubed, so you know, there's no number there. So what you can do is you can factorize your quadratic to 3x minus 1 and x plus 2, and that multiplied by x plus something will give me the cubic. Okay, using the factor theorem, I can say then that 3x minus 1 is 0, then x would be a third, and I can also say that if x plus 2 is equal to 0, x is minus 2. If I substitute these two values into that original cubic, then I'll be able to form a simultaneous equation that I can then solve. So let's have a look at this when I substitute in a third. So f a third is equal to 3 lots of 1/3 cubed plus 17 lots of 1/3 squared plus a 1/3 plus b, which when you calculate all of this out, you will end up with 1/9 plus 17 over 9 plus a over 3 plus b. Okay, and because I know that x is 1 over 3 will be a factor, so 3x minus 1 is a factor of this, then I can say that all of this should be equal to 0, because f 1/3 should give 0 if it is a factor. So tidying this up and solving it will give me 0 is equal to 2 plus a over 3 plus b, which is minus 2 is equal to a over 3 plus b. And because I don't like divisions when I'm doing simultaneous equations, I would actually multiply 3 by 3 to say minus 6 is equal to a plus 3b. Okay, so that's 1/2 of my simultaneous equation that I'm going to look at in a second. When I substitute 1/3 in, make it equal to 0, get one side. Now I'm going to do the same thing but with minus 2. So let's say f minus 2 is equal to 3 lots of minus 2 cubed plus 17 lots of minus 2 squared plus a minus 2 plus b. Again, f minus 2 should give the solution 0 if x minus 2 is a factor. Sorry, x plus 2 is a factor. Yep. So I'll simplify this all down. It should leave you with minus 24 plus 68 minus 2a plus b is equal to 0. Take everything to one side, leaving you with 44 is equal to minus 44 is equal to minus 2a plus b. Okay, now that I have these two equations for a and b, I can use simultaneous equations to solve this. So I'm just going to rearrange this equation here and say a minus 6 minus 3b is equal to a, and then I'm going to substitute that into the equation here, giving me minus 44 is equal to minus 2 lots of minus 6 minus 3b plus b, which is minus 44 is equal to 12 plus 6b plus b, which is minus 44 is equal to 12 plus 7b, so minus 56 is equal to 7b, so b is equal to minus 56 over 7, which is minus 8. Okay, now I found minus 8 for b, I can substitute it back into either one of these two equations to find a. Okay, and I'm running out of space here, so I'm just going to go into in fact, I'll just do it in the top right. So minus 6 is equal to a plus 3 lots of minus 8. Minus 6 is equal to a minus 24. So a is equal to 18. Okay, so I've now found a and b. Sorry, well, that's not b. A and b down here. Okay, which answers the first part A. Find the value of a and find the value of b. Okay, so I can rewrite my equation, this equation, as 3x cubed plus 17x squared plus 18x minus 8. Okay. Now, b says, hence factorize the polynomial completely. And there's two ways of really approaching this. Either, now I know my polynomial and I know that 3x squared plus 5x minus 2 is a factor, I can use long division to divide my polynomial by my quotient to get, polynomial by my divisor to get a quotient, which will allow me to factorize it, as I've already managed to factorize the first two brackets here. Okay, and that should leave me with one bracket that I can then combine into an answer, which I'll do an example of in a second. Or I can use my knowledge of this line here to just work out, well, what C must be and what, theoretically, I could have said there was another number in front of here, D, but there's not, okay? And I can just use that. That's called Equating Coefficients method. So first of all, I'm going to look at the long division method. It's the more thought out and logical method, whereas the other one is a bit of mental mathematics. So let's do the one that I just mentioned first. So we're going to do long division. 3x squared plus 5x minus 2, and we're going to divide 3x cubed plus 17x squared plus 18x minus 8. Okay, so the first thing I need to get rid of is the x cubed. So to get rid of x cubed, I need to multiply this 3x squared, my quadratic, by x, which gives me 3x cubed plus 5x squared, make sure that looks like a plus, minus 2x, which I'm going to take all away, leaving me with 12x squared plus 20x, carry down my minus 8, minus 8, and then I'm going to divide the 12x squared plus 20x minus 8 by, then I'm going to say, what do I need to multiply this by? 3x squared, my quadratic, to get rid of a 12x squared, and that will be 4. So I'm going to multiply this through by 4, 12x squared plus 20x minus 8. And as you can see, when I take those two away, that leaves me with 0, telling me and proving that 3x squared plus 5x minus 2 is a factor, as well as giving me what the other bracket must have been. So my solution to the factorize a polynomial completely will involve a 3x minus 1 and x plus 2. So 3x minus 1, x plus 2, and then what I've just calculated, x plus 4. If I had ended up here with a remainder, then I must have made a mistake in calculating my a and b. So that's a good test to see if you've done it right. The other method for finding this, so I'll just call this method 1, is by saying what must the coefficients be. So as I showed a second ago, I've already calculated 3x minus 1 and x plus 2. I'm trying to find out what's in my third bracket that will allow me to get 3x cubed plus 17x squared plus 18x minus 8. And as I mentioned in the first part, I know that this bracket will have a single amount of x in because I want 3x cubed, and I've already got 3x times x, so I can only multiply it by x to get 3x cubed. So I know there's no number going to be in front of that x. The other number that I need here, I can find out by thinking about my constant at the end. So to get the constant, that's just by multiplying the three non-x terms in your brackets together. So I've got minus 1 times 2 times something, giving me minus 8, and you can work out that that must be 4. So that would be my second bracket here, x plus 4. Okay, just do that all in blue. So that's the other method. It's a bit quicker. Well, it's a lot quicker, but it takes you need to completely understand how to get that bracket based upon what we had a second ago. Okay. Lastly, we're going to look at this question here. Okay, even less information than what we've looked at before. So it just says solve x cubed plus 4x squared minus 19x plus 14 equals 0. To solve this, there isn't a method like with the quadratics where you can just factorize down into two brackets and do a bit of trial and error in your head to get the numbers in, or use the quadratic formula. There's no cubic formula. So we've got to use fact theorem to help us. Okay? And fact theorem, as we said a second ago, is if you substitute in a value and you get 0, then that must be a factor. Okay? Then x minus c must be a factor. Okay? Or if I was to say this a bit better, if I was to substitute in my, is it b over a? Yep, b over a is equal to 0, then ax minus b must be a factor. So what you've got to do here is you've got to come up with what you can substitute in to get 0. So it's a bit of trial and error, okay, to begin with. And then we can use long division and the equating coefficients to help us after that. But firstly, you've got to think of what numbers, when substituted into here, will give an answer 0. Okay? One of the ways to think about this is to do with our constant again. Okay? Plus 14. If I've got 3 brackets, and I need to get 14 at the end, that must mean that these 3 numbers here, when multiplied together, should give the answer 14. Okay? And there's multiple different ways of that happening. I can have 1, 1, 14. I could have 1, 2, 7. I could have 1, 4, that's pretty much it. 1, 2, 7. Is there any other ways I can do it? No, I don't think so. Okay? So you've got to think about what 3 numbers when times together can produce a 14. Obviously, I can also have some of these as negatives, so I could have minus 2 and minus 7 potentially. And what we're going to do is we're going to try and find what numbers fitting in here will make sense. So all I've got to really try is, are these 3 numbers, well, plus or minus 1, plus or minus 2, plus or minus 7. If I substitute these 3 numbers in here, whichever ones produce a value of 0, if any of them produce a value of 0, then I can use that to find one of the factors. Okay? So let's start off with plus 1. Let's find out what f1 would look like. So 1 cubed plus 4 lots of 1 squared minus 19 lots of 1 plus 14. What does that equal? Well, luckily enough, if I type that into a calculator, I do get the answer 0, which tells me that one of my factors must be x minus 1. Okay? Because if positive 1 gives me 0, then x minus 1 must be one of my brackets, because if I was to sort of reverse engineer it, if I was to say x equals 1, then I would say that x minus 1 is 0, which is how we get our brackets. Okay? So now I know that x minus 1 is a factor. I can substitute that factor into a long division, or I can use the equating coefficients that we looked at a second ago. Okay, so starting off with long division, x minus 1 going into the polynomial x cubed plus 4x squared minus 19x plus 14. Okay, so to get rid of x cubed, I need to multiply through by x squared. So x cubed minus x squared, take it away, leaving me with 5x squared, bring the minus 19x down, minus 19x, bring the 14 down, plus 14. How do I get rid of 5x squared? What do I need to multiply x by? I need to multiply it by 5x, giving me 5x squared minus 5x. take that all away, leaving me with minus 19x minus 5x is minus 14x plus 14. Okay. What do I have to multiply x minus 1 by to get rid of the minus 14x plus 14? Well, I need to multiply it by I need to multiply it by minus 14, giving me minus 14x plus 14, and if I take that away, that gives me 0. So as you can see, when I divide through the cubic by x minus 1, I do get the remainder 0. Also again, proving that x minus 1 is a factor. Okay, so I can say I've got x minus 1 and x squared plus 5x minus 14. Okay, this is not yet factorized and solved. Make it equal to 0. Because I need to now factorize my quadratic, but because it's quadratic, you factorize quadratics many a time, hopefully. So you get x minus 1, and these become 2 brackets, x and x, 2 numbers at times to make minus 14 and add to make 7, 5 is 7 and minus 2, equal to 0. That means that I've got the solutions x equals 1, x equals minus 7, and x is equal to 2. Those are my solutions for the solve x cubed plus 4x squared minus 19x plus 14. So that's using long division here. Again, I can use the method I talked about a second ago, equating coefficients. So I could have said I've got x minus 1, I've got an unknown ax squared plus bx plus c, as in I don't know what the quadratic is when I factorize it down, and I know that's going to equal 0. However, I know from my original equation, the x cubed plus 4x squared, let me just write that above, x cubed plus 4x squared minus 19x plus 14. I know from this original equation that in terms of x cubed, there's only one lot of x cubed, so that must mean that my a here must equal 1, because x times x squared will give me x cubed, and I must know that my c is minus 14, because minus 1 times that gives me a positive 14, so I can say x minus 1, well I don't need a 1, 1x squared plus bx, still don't know bx, minus 14 is equal to 0. Okay, as I, oh sorry, not b, c. Okay, now that I've written it this way, I can use this to help me find out b, but finding out b using this method is a bit more complicated. What you've got to think of, what terms give you x terms, okay, in terms of trying to find your minus 19x, which is minus 1 times this, and minus 14 times x. So minus 1 times bx plus minus 14 times x will give me minus 19x. This comes down to bx plus 14x equals 19x, so b must equal 5. Okay, so I get x minus 1, x squared plus 5x minus 14 equals 0, and then same as before, I can factorize that down, make it equal to 0, and find the solutions. Okay, that's a complicated way of answering it, but I much prefer the division method. I think it's more logical rather than a bit mental maths trial and error. Okay, hopefully you understood that. I know it's a complicated topic. Good luck, and I'll speak to you again soon.